Hello, everyone. This is Keith Jackson, and welcome to Jack's Math Notebook. Right now, you're looking at three examples that will explain how to interpret the slope of a line. But before we determine the slope of these lines, let us give you the slope formula in which we have delta y over delta x, which really means the change in y over the change in x, which also means y is over run, which means m, which is the term we use for slope. And so we have y equals mx plus b. I hope that sounds familiar because we're going to use that to help us understand the slope of this given line. But what we're going to do, instead of using the slope formula to help us understand it, we're just going to stair step it to see if we can determine the slope from the line itself. And so let's take a look at a couple of points right here. Let's take a look at 0, 1, and let's take a look at 3, 3, and let's see if we can arrive at the slope that way. And so when we do that, we can rise 1, 2, we can rise up 2 right here, and that will give us our numerator of 2. And then we can go over 3, 1, 2, 3, and we land right there. And guess what? We ran 3 to the right, and that will be our denominator. And so that will give us a slope of 2/3. And to complete this equation, we could just say that y is equal to 2/3 x plus 1, because as you can see, this line crisscrosses y at +1, and that's why we have this linear equation as you see right here, keeping in mind that our slope is 2/3. We have our rise, which is 2, over our run, which is 3. Now let's take a look at what a zero slope may look like. And here's what it might look like. You will see that there will be a 0 in the numerator, okay? And here's why that will happen. And when there is a 0 in the numerator, you will just simply have a flat horizontal line, just like you see here, and let's prove it to you. So let's take 2 points along that horizontal line, 2, 3. Here is 2, 3 right here. And let's take 5, 3. And so we have 5, 3. And guess what? In that y position, we have the same value. We have a 3 here and a 3 here. And watch what happens when we plug it into this formula right here, which is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. When we plug those in there, right? So we have a 3 minus 3 in the top part, in the numerator part. So 3 minus 3 will give us 0. And then we have a 5 minus 2 in the denominator part, which will give us 3. Because we had that 0 in the numerator, the slope will be 0. The slope will not go up or down or in a given direction. It will just be a flat horizontal line, just like you see here. And this is why y just simply equals 3, because no matter what the x value will be, y will always be 3 because of this horizontal flat line. Let's take a look at another example in which we will have 0 in the denominator. If there is a 0 in the denominator, the slope is considered undefined, meaning that it's just going to be a vertical line, just like you see right here. And here's how we can prove it to you. And so let's take 2 points along this vertical line, like 3, 5, and 3, 2, noticing that there are that the 2 3's are in the x position as it relates to these coordinates. All right, and so let's plug it into the y sub 1 minus the y sub 2 minus y sub 1 and the x sub 2 minus x sub 1 and see what happens. And as you notice in the denominator, we have a 3 minus 3, which will give us 0. And we have a 5 minus 2, which will give us 3. That 0 in the denominator will make this slope undefined. It will just make it a vertical line at x equals 3. Okay, you have been given quite a bit of information. I wouldn't blame you if you need to pause the video just to take a look at these 3 examples, or replay this video as many times you need to gain a deeper understanding of this particular concept. But in the meantime, please comment, share, like, and subscribe to Jack's Math Notebook for more content. Thank you and goodbye.